Hello, everyone, and welcome to this week's Believe in Serverless webinar. I am super excited to have you all here, wherever you are, YouTube, Twitter, Twitch, wherever that might be. It is super exciting to have you here. Before I introduce this week's guest, I'd quickly mention the other events that we've got going on this week. So in a couple of hours' time, I will be back on these kind of screens somewhere, talking about all things event-driven architecture and event-driven systems. So if you're interested in EDA, make sure you check that out. And then on Friday this week, Danielle and Omid are going to be talking about all things Cloudflare workers, which is going to be super cool. Something I've played around with a little bit myself. And yeah, it's a super interesting serverless technology outside of the kind of AWS ecosystem. So that's going to be super, super cool. But with that, I will get on to this week's guests. And if you'll just indulge me for a minute, actually, because this is a massive honor for me, because a few years ago, every time this man to my left, right, whichever way, every time he released anything, podcast, YouTube, I was there watching it. So actually, to be here now with you, Luca, and chatting and hosting you, it is a massive, massive honor. So yeah, Luca Mezzalira, thank you for being here.
Oh, thank you. Thanks for having me. It's a pleasure helping the community. You know how passionate I have with about the communities in general. I grew up with the communities, and therefore I'm trying to give back as much as I can.
Yeah, awesome. Well, again, thank you for being here. So with that, actually, Luca, I think I will just hand straight over to you. Everybody, if you've got any questions, any comments, anything you want to pose to Luca, then drop it in the chat. After Luca's finished doing his thing, then we'll put some questions back to Luca if you have any. So please keep questions coming. And Luca, over to you, my friend.
Thanks. So let's wait. We have okay. So we can see the slides now. So hi everyone, and it's a pleasure being here. My name is Luca. I'm a serverless specialist based in London. I work for AWS, and it's 3.5 years I'm working for AWS. And before I was a customer of AWS using Lambda. And Lambda was something that speaks to my heart very quickly because it was simple. It does the job that I need to do. And then I started to drill down more and more. And now, as a specialist, I'm able to, let's say, go really in deep about how Lambda works behind the scene and what are the best practices for optimizing that. And that's the reason of this talk, right? So trying to provide, let's say, a first-hand experience on what I've seen that is working and how to improve the performance of Lambda. I'm going to talk about mainly Node.js because I work with several languages in my career, but Node is the latest one that I embraced, and therefore I'm using that. But bear in mind, several of the optimizations that I'm talking about will be available for other languages. So let's start with that. So what we're going to cover. So we start first to understand quickly the function lifecycle, because if we understand that part, then it becomes easier to understand where we can optimize, because it's not always, let's say, straightforward, especially for people that are for the first time looking into Lambda. I built like a solution that is optimized and unoptimized, as I call them. Sorry, I'm not great with names. As we know, is the most difficult things that the developers has to deal with, naming, let's say, your code and your projects. So I went with a very poor unoptimized and optimized version. So we'll drill down into that. And then we continue with, let's say, how to improve the approach. So we move from how, let's say, a developer would build an API using Lambda and in this case Postgres with RDS, and then we see what kind of optimization we can have and how much we can squeeze in. Perfect. So let's start with Lambda under the hood. So this is basically what usually Lambda looks like, a very high level behind the scene. So when you are invoking a Lambda, all the, let's say, box that you can see, the red, white rectangle you see there, is basically what's happening behind the scene. So in our case, we have an API gateway that is going to call in a synchronous fashion at front end. There is, let's say, the assignation of this job to a worker. The worker will spin up your micro VM, and it's basically here where the magic happens. In this specific place is where we can optimize our code, because the rest is managed by AWS, right? So one thing that we need to bear in mind that every time that we write code and you spin up, and you have multiple requests, and we spin up multiple micro VM inside the worker are distributed through availability zone, and therefore that is out of the box for you. It's our way to maintain the high availability on the service, but obviously we need to factor this when we are thinking about optimizations. One thing that we need to clarify is that when we spin up a new micro VM for you, this is what's going to happen. I picked this diagram that for me is available in the extension documentation of official Lambda docs. That for me is the one that speaks volume on how it works behind the scene. Because when I was VP of architecture in my previous company, very often I was designing sequence diagram to explain better what we wanted to express, and I think this visual helps a lot to understand what's happening behind the scene. So we have three phases that are key here. So we have the initialization, the invocation, and the shutdown. The one that we can, so these three phases here. The one that we can really affect is the initialization phase, so the function init, so not the runtime initialization or the extension initialization. That is not something that we can, let's say, impact. But what we can impact is the function init, so what's happening before, let's say, the Lambda function or the handler inside the function is invoked, and obviously the invocation. Those two phases are the one that we are looking at, and we are trying to leverage as much as possible these, let's say, phases in order to optimize our code. Okay, so let's start with the two solution. We start first with the unoptimized solution. Okay, so this is let's say a very simple approach where I created this let's say this architecture, very simple synchronous API that is exposed through API gateway. Lambda is VPC attached, and therefore it's communicating with RDS, with RDS and RDS proxy in this case for retrieving data from Postgres database. Obviously, we instructed also our Lambda function to, let's say, write on CloudWatch using X-Ray for distributed tracing. We set up all the IAM rows in order to make that happen. And also, finally, we use a parameter store in order to retrieve some information related to Lambda. If you think about that, this is the classic thing that you would do when you are building an API using Lambda, right? So there is nothing too crazy. The only thing I want to let's say, highlight here is that very often what I've seen with customers that for the first time are dealing with Lambda, they tend to leave the architecture as x86. That is the one that I have seen quite often, let's say, used at the beginning when people are approaching Lambda. And therefore, I used, in this example, also the x86 approach. Okay, so first and foremost, when we start to write the code, one of the best practice that is happening, or better, that we suggest, recommend very often, is using, let's say, the parameters or any connection that's happening to a database outside the handler. Because we say that at the initialization phase, we create this connection, and that enables us to not then reapply every single time when we call the handler. Because if we take this code and we put inside the handler, then it means that we need to call it multiple times every time that there is a connection, every time there is an invocation of Lambda function. Therefore, one of the suggestions when you have parameter store, secrets manager, is putting that outside the handler. Therefore, when they let's say Lambda function and sandbox is up and running, then we just execute the code inside the Lambda handler, but we reuse the connection to parameters or the storage of certain properties outside the handler across the specific sandbox that is running the Lambda function, and therefore we can reuse that part. So that is, let's say, a very easy thing that we have implemented. We follow the best practices, so all good. Now, one thing that I showed in the diagram before, and often is not very well known, is RDS proxy. So RDS proxy is a service that is doing something very useful for you. It's used with in conjunction with RDS. Obviously, you can use for MySQL and Postgres, and it takes care about the connection pool. Usually back in the days when I started to use Lambda in 2016, if you wanted to connect and something like that, before there was RDS proxy, you need to take care about your connection pool. Now it's not needed anymore if you're using RDS proxy. But moreover, also you delegate the, let's say, certificates management and secrets to RDS proxy. That means that you have, let's say, a smaller image size of your Lambda, because the certificates currently are living outside, and in the latest runtime available, we currently remove the certificates if you want to use that by your own. In order to let's say use directly inside the Lambda, you need to activate that. So bear in mind that thing if you're using, for instance, Node latest version. Okay, so the other thing is one of the best practices we usually recommend is using the minification of your code. Why that? Because we know that the less code you use for inside your Lambda function, the faster will be your retrieval, because you minify, the file size will be smaller, therefore you have less kilobytes that are moving across the network, and so on and so forth. And that usually is a good practice. You can remove all, obviously, with minification also all the comments and everything, so you reduce the size of your final system. By the way, if you're not aware, out of the box, when you're bundling, in this case with CDK, but you can do also without CDK, you can still bundle your code in TypeScript and Node.js. You can also, so we're using here ESBuild, that is the default option that is available in CDK, but obviously you can also decide to first bundle with whatever bundler you want. If you want to use RSPack, you want to use Webpack, or whatever you prefer, you can do that. So it's not that you are bound with that. Here we are talking mainly about ESBuild, because it's the one that is offered by default. The other thing that is important to define is also the format output, the output of your bundler, and in this case is ESM. Why that? Because ESM allows you to have top level await. That is basically the code that we have seen before, that allows us to make an await before the handler is done. And in this case is usually useful when you want to, let's say, retrieve some information that are stable enough for living inside the let's say execution time of a sandbox. Therefore, ESM definitely is something that I personally recommend. The other thing that is interesting here is that you can also define certain modules that are external. So those, let's say, modules will be downloaded and available inside your sandbox, and not bundled together inside your code. The other thing that we usually recommend is the usage of power tools. In any given point, if you're creating an API, is you really need to, let's say, identify or create the observability around your code. And then you want to have logs, you want to have metrics, you want to have, let's say, tracing, and so on and so forth. PowerTools is an open source project that is available not only for TypeScript, but also for other languages like Python, Java, and C#, etc. And the beauty of this approach is that it's basically built in all the best practices we recommend in order to manage observability inside our system. And therefore, in this case, you don't have to think, oh, I need to create a library for doing structure logs, or I need to use this specific configuration. You just leverage, let's say, a tool that is, or better, a library that is available and is updated for you, that is joining all the learnings from different service teams as well, customers, in order to do that. So here, for instance, as you can see, we are using MIDI for integrating our PowerTools solution or library. MIDI is a middleware that is an open source that was created by Luciano Mammino, that is an AWS hero, and is a solution that is widely used, I would say, in Node and Lambda. Therefore, I highly encourage you to see it and check it if you didn't. And this is, let's say, also from the official documentation of PowerTools, where we recommend to use MIDI for integrating with PowerTools. It's not mandatory, but we recommend that. The other thing is of power tools to take into account that there are a lot of butter included things. So for instance, one thing that I really like and I use extensively in this example, when I want to understand how the performance of a specific chunk of code are behaving in production, what I'm doing is usually creating a segment inside X-Ray. And in order to do that, as you can see here, I have this code that's very simple. That basically is checking when I retrieve all the stadiums of this API. I check how long it takes that specific operation, and then I can start to apply on multiple part of my code, so I can understand where is my low-hanging fruit that enables me to optimize my code better. Otherwise, we start to guesstimate or trying to figure out or assume what is the main offender, and we might not have data points that are backing up our ideas. So that is definitely a good way to do that. As you can see, also have logger and metrics in order to understand how many requests to the stadiums we receive and the total stadium retrieved, because maybe I want to check that we retrieve all of them. At the same time, you can use tracing not only inside the code if you need to just isolate a portion of the code, but you can do also for the entire function, or better, for a method inside a class. So in this case, as you can see, we are using a decorator, so you can say at tracer, that is then will be translated in a function that wraps basically the other function that is needed for authenticating to database. So the other thing that I want to share with you is those are the things that we have implemented in the unoptimized version. But obviously, in order to tell you how we can optimize, usually we need to create a baseline. And the baseline for me is very important. One thing that I always recommend when you're dealing with serverless, no matter your, let's say, maturity and expertise, is always testing your code using load testing, because you need to understand how the things are performing in reality. Now, in this case, what we are using is doing load testing with artillery. This is a Node.js library for doing that. And we started to do from 45 seconds to 2 minutes. So that's how I designed that thing. And then we move from 0 to 20 virtual users to 100 virtual users, stuff like that. So this is basically the methodology we use to test our code and understand where we are heading to. Perfect. So the first thing is looking into cold start. And there is a nice trick that is available on Serverless Land. I posted here the link where you can see the query for understanding how many cold starts you have. So this is something that you will benefit when you are understanding better how your system works, especially if it's an API with Lambda. So the first test works in this way. We have a 10-second ramp up from 0 to 20 requests per second, and then we move to 50 seconds sustained load to 50 requests per second. Okay. So these are, let's say, the outcomes. So as you can see here, we have 18 cold start that you can see here at the top of the diagram. And when we look into this, let's say, this response of this simple API that is querying from Postgres, returning back a response with all the NFL stadiums available in US, we have, let's say, a P95 that was slightly below 500 milliseconds, but the P99 was over 2 seconds. Okay, so this is, let's say, how long would take for this specific ramp up. So let's try to drill down into the data. So the worst cold start was 1.43 seconds. Why am I highlighting this part here? Because this part here is the one that we can affect. If we start to understand what's the baseline that we have, we can start looking into how to optimize our code. And here you can see that there is a breakdown with the initialization phase, that we have in the invocation, a bunch of things that are happening. And those like hashtags that you can see here, you can see that there is a breakdown that are basically where we are spending time. For instance, for a trillion parameter, we spend 586 milliseconds. So those kind of things are very useful to understand how the things are working behind the scene. So this is the worst cold start. When we move into the best cold start instead, we have 1.2 seconds. Okay, so we move from 1.43, and the best one that we had was 1.21 in these 18 cold starts. So If you remember, we have like 50 requests per second, and therefore we don't have many sandboxes that are needed in order to fulfill all this traffic. We just have 18 cold starts. So that's one thing that I want to highlight, because usually people are afraid about cold starts, but cold starts are a small portion of your traffic. In the warm start, so now the sandbox is already up and running and start just to execute the code, we have instead 228 milliseconds as response time, and we have the best one is 167 milliseconds. That is not bad. If you think about that, we did like bare minimum optimization. We didn't spend too much time on that. We just followed the best practices that are provided by AWS and by other from the community, and that's what we get. That might be more than enough for you, but that's not, let's say, the exercise that we are into it, right? So in the second test, we change completely the approach. Instead of having a nice ramp up from 0 to 20, and then we move from 20 to 50, so we have some sandboxes that were available. Remember the first diagram that I show you, where we divided the work across multiple workers across different AZs. In this case, we start from 0 to 50 requests per second, straight away. And as you can see here, we have 137 cold start. It's completely different the things. And now the P99 returns like over 4 seconds. Okay. So this is, let's say, a different kind of test, but obviously it tells you how we are behaving in this case. Okay, perfect. So this is what was the unoptimized version, right? But let's try to improve the Lambda function. The goal of this exercise for me was, okay, let's try to build something like everyone would do. And then I start to optimize step by step. Let's see how much I can squeeze in. So for the optimized solution, there is a new, let's say, icon in this diagram. And that icon is an Amazon Elastic Cache. Very often, we have different layer of caches that we can apply inside our APIs. And even if you have, let's say, very dynamic APIs that might change every minute or wherever, even if you cache for a small amount of time, could be like, I don't know, 10 seconds, 30 seconds, is going to offload a lot of traffic. The performance will be better. The scale that you have to onboard on origin will be lower, and therefore it will make your life easier. So if you have different layer of caching, you can cache in the browser, you can cache in the CDN, you can cache through API gateway, but you can cache also with in-memory cache. So in this case, I decided to go with Elastic Cache in order to keep it simple and focusing on what you are in full control. As you can see here, we have more or less the same architecture, nothing changed, apart that I also changed the architecture to ARM. Because ARM might provide some benefit, because we are not doing anything specific to x86 architecture, and therefore ARM will provide some benefit, because we're using Graviton2 behind the scene. That is, let's say, a solution based on ARM that will enable you to save in cost and probably have also a good performance, up to 20%, if I remember well. So the Lambda logic that we will apply for this specific caching is a classic cache aside pattern, right? So you just make a request to the Lambda function that is checking if in Elastic Cache there is something that we can return. Otherwise, it will perform the request to RDS. And bear in mind that this is a pattern that I've seen over and over again, and it might help even if you have a partial response that is cached, and you can use partially, especially when you have multiple endpoints that you need to retrieve in order to respond back to the requester. It can be a good strategy that you can apply. Now, one thing that I noticed while I was starting to drill down into my code is that the unoptimized solution with the library that I was using, it was the final output was 1.6 meg. Now, I wasn't doing anything crazy. I was literally, let's say, checking the request, and then I started to perform a query to Postgres, and then retrieving the information and sending back. So I'm not doing anything particularly crazy. And what I realized is that the problem was the library that I choose for this specific implementation. So looking into the library, looking on the composition, I discovered that it doesn't allow me to do tree shaking, and therefore I need to find something else. And when I switch into Postgres.js, literally exactly the same code, changing the library, using the implementation just for communicating with my with Postgres, with my database, I was able to squeeze in to way less. Now, this is not exactly the data that I have seen. 246 kilobyte is the final, let's say, value of the package when I started to introduce other implementation. But what I was able to use, so this one includes also the Redis library that I'm using currently for this final implementation, but without the Redis library, just literally moving from the previous libraries to the new ones, to PostgreSQL, I was able to move from 1.6 meg to 40 kilobytes. Because that library, so PostgreSQL, is tree-shakeable. So I can remove all the methods that I'm not using in order to perform my performance. And therefore, the main takeaway here is try to check your libraries, try to understand if the one that you're using, that might be the most popular one, is heavily optimized for what you're doing. Okay, so the other thing is, yes, we have minification, but we also added reshaking that helps. Remember that this is one thing that I highly recommend every time, to remove everything that is not using. And when you are importing, especially in ESM, this came quite handy. Yeah, you can do also with CommonJS, but in ESM it's let's say quite handy. You can do tree shaking and remove everything that is not needed, so that becomes very easy. The other thing that we have done when I started to look into the system is, okay, so before I didn't look into the memory size of a Lambda. I just guesstimate what would be, considering that I was just reading from a database. I said, okay, so maybe 256 megabyte will be more than enough, right? But in reality, we can use power tuning to be more deterministic. So power tuning is an open source tool you can deploy into your AWS account. It will basically deploy a step function that tests in parallel multiple execution of your code that you have written inside a Lambda function with different memory size that you define. And basically what we were looking here is, because we were using 256 megabyte for this specific Lambda function, the unoptimized one, we see that the invocation time, that is this pink line, it was quite slow, and the cost was here that, yeah, it was relatively cheap. But if we look slightly, we move slightly on the right side, we see that 512 meg, that is even cheaper than the 256 meg. It will perform like almost 800 millisecond less response time compared to the 256. So probably we need to look deeper into that. And this is, let's say, an issue that I've seen very often with, let's say, developers that are starting to work with Lambda, that they think that the lower amount of memory corresponds to lower price. And the answer is not always. So in when I started to use power tuning for the optimized version instead, I started to have like very interesting output. So if you look into that, we found the sweet spot here, where if I move to 1 gig, I can have like really interesting response time. And what does it mean? What is translate this response time? Why is it important? So if you think about what we were used to do, or what we are used to do with containers, is that usually you look into the transaction per second. But in a second, you can execute the same Lambda function multiple times. And therefore, what it means that if my Lambda function has a response time that is faster, obviously faster than 1 second, then I can have maybe 2, 3, 4, 10, 15 requests that is handled by a single sandbox. So I'm not, let's say, I have less code start, and I can think also of heavily optimize my code to have better performance and better cost. So in this case, looking into power tuning, the suggestion would be moving to a gig. The other thing that I did, and this is mainly because I think not many knows, there is a parameter store and secrets manager extension that is built by AWS. An extension is nothing more than a sub-process that is working in the same execution environment of your code. And therefore, imagine like having a local server that you can communicate from your code that is running inside your Lambda function. The beauty of this thing is that there are two separated processes, right? So as we have seen at the beginning, the first thing that we are going to do is when an extension is available, is opening starting the extension, and then we arrive at some point at the initialization of your Lambda function. So here, with this parameter store, what we can do is just communicating through a bunch of, as you can see, a bunch of common environment variables with the extension, selecting the port, selecting the TTL on how long you want to store the let's say the data from parameter store into your extension. And what it means is that basically we imagine that we are communicating from our Lambda function instead of straight to parameter store to the extension, and the extension takes care to communicate with the parameter store. What's the advantage? The advantage is that you don't have to deal with multiple, let's say, requests that has to be handled by you for deciding how long is cached. You can instruct a sub-process to communicate when is needed with the service, and moreover, it will take care of doing the cache aside pattern for you. And that is fantastic because it means less code to handle, and you have, let's say, a very nice experience overall, also for handling your parameter store or secrets manager. Here, as you can see, there are quite a lot of, let's say, knobs that you can use in order to tweak your system in the way that, that you want. And the other thing is that in order to implement the integration is very easy. So here you can see that we adjust the communication through localhost that is happening to the system manager / parameter. You pass the parameter ID, and you pass another important thing that you need to pass is as a header the session token that is available inside the environment variable of your every single Lambda function. So you take that and you pass into the header as X AWS parameter secrets token, and off you go. You have your integration with this extension. Easy, right? When we started to do the same test that I was doing before, now we start to have a completely different, let's say, numbers. So if you remember well, the first test, we had like 18 requests, 18 cold starts in this journey where we have 0 to 20 requests per second in 10 seconds, and then sustained load of 50. So we have half of them just adding a cache, just looking into the right memory size, just optimizing the bundle size, and so on and so forth. The other thing is that we start to drill down into the performance. Now we have less than a second for the worst cold start. That's an interesting data point, right? So we have like 794 milliseconds. Interesting, right? And when we look into the best cold start, we are already half a second. So great results so far, right? However, when we look into the worst warm start, we move considerably the needle here, because it's now that we have a sandbox available, we have 73 milliseconds of response time. The best warm start, though, arrived to 6 milliseconds. And by the way, I'm not using Rust, as my friend James would suggest to do. I'm using TypeScript, okay? So I'm not doing anything crazy. I'm just optimizing based on my workload characteristics, what I can do in order to have a great response time. The second test, the one that we start from 0 to immediately 50 requests per second, suddenly we have like 9 code starts. And that is a great achievement. If you see now, the P99 is very close to the P95, and is definitely under the 500 millisecond. I would say that is, looking at this diagram, probably 200 milliseconds, something like that. So the beauty of this approach is that when we start to look into, we do the comparison between the unoptimized, let's say, duration and the optimized duration, is considerable what we are doing on the average, right? So this is like classic average that you can do. And that is fantastic, because we didn't do many things, right? We just started to look into the few parameters, and off you go, you have what you need. Also, I added an environment variable that is available in order to understand what would happen if I activate the Elastic Cache, or if I don't activate Elastic Cache. And you can see that there is definitely some value on having that, but I get that maybe people would complain, okay, look, if we do in that way, we increase the cost. And it's always a trade-off, right? When we are dealing with the solution design, we need always to think what are the things that we need to take into account, and what is, let's say, the real revenue that is return of investment that is coming in. And therefore here, for instance, you can see that using cache or no cache is an important part of it. Perfect. So what we have seen on this, that if you start to spend time optimizing your Lambda function, you might risk that you can have, like in this case, an improvement of cold start of 56%, but even more interesting, an improvement of warm execution of 95%. That for me is a testimony that investing time into looking how your workload works and define that will enables you with not crazy things, just using the tools that are available out there. You don't have to like to rechange completely an algorithm, a complex algorithm, whatever. Maybe also, yes, it depends from what you're doing inside the workload, but in general, you will have, let's say, considerable benefit that will enable you to better work when you deal with Lambda functions. But there is one more thing that I want to talk about today, and I know that this community have already seen a bit, but I want to look from a different perspective. So LRT, that is one of the customer runtime, was created by a colleague of mine that did a fantastic job of creating this solution that is using Quick.js, is built with Rust, and provides, let's say, a good environment for running JavaScript that is amazing. Offers what is claimed up to 10x faster startup and 2x overall lower cost compared to other JavaScript runtimes. So definitely it's a very interesting approach. And there are some limitations due to what is supported inside Quick.js and this customer runtime. But in general, you know, it's very interesting. So if you're interested to know more, you have like the link here, but moreover, you can watch the recording of Believe in Serverless, and correct me, James, if I'm wrong here, but you should have available already the recording with Richard. Okay, so this is what you have inside LRT. That is, let's say, you know, the classic example that you have, like you're reading from DynamoDB, or better, you are inserting a new content or updating a content in DynamoDB. And with LRT, 128 megabyte, you can see that is extremely fast. The P99 compared to compare between the two with the Node.js runtime is very, very fast. But what I did is like, let me try to do by myself, because I want to be in the customer's shoes. I want to see how these things could benefit. And thanks, James, for sharing the recording in the meantime. And here you have, let's say, a classic example that I created that basically is nothing more than an API gateway that, or better, HTTP API that is communicating with a Lambda that is VPC attached to EFS. And EFS is a network file system that enables you to store files, obviously, as the name suggests. And in this case, I just stored like 1 megabyte of file, just to see how fast the LLRT would compare with the node inside, with the VPC attached Lambda function. So node 512 meg. The code start and response time was 700 milliseconds, while LLRT, same, let's say, same memory size, and everything was 160. So this, for me, is a good testimony that we are going towards the right direction. Also with LLRT, obviously still early days, but you know, we never know what's going to happen in the future. So few takeaways of this session, just to provide you, let's say, the TLRD for this session. So first of all, choose your library wisely. It's important that you will look into your library. There are plenty of tools that enables you to do that and inspect your library, understand what is the main offender, understand if there are other alternatives that will make your, let's say, system lighter. Use cache where possible. It could be memory cache inside the Lambda function. It could be Elastic Cache. It could be API Gateway Cache. It could be CDN. It could be in browser. But try to figure out what is your caching strategy, because that is very important. Bear in mind, the more you can cache before you hit the origin, the lighter will be the traffic that you have. And I can tell you, before as a customer of AWS, I was leveraging a lot caching because I have like a very spiky traffic pattern moving to 10,000 to millions of requests in a minute. And therefore, I need to find a way to not, let's say, hit the origin every single time, millions of times per second, because otherwise the architecture would be completely different. So try to leverage cache as possible. Extension could be your solution in certain cases. We have seen today the one for parameter store and for secrets manager. There might be more that you can look into and see if that will help you to achieve what you need. And last but not least, bundle size matters. Remember always that if you can optimize that, remove the code that is not needed, and you can let's say, use only the parameter and the function that you use inside the library. That will make your life easier, your bundle size smaller, and obviously the execution of your Lambda faster. And LLRT, keep an eye on that, because you never know that it might be, let's say, the solution that will, let's say, make you even faster. So all of these gotchas and everything that I have discussed is written also in an article that is available at this link here. And there you can find also the link to the GitHub repository in order to test the code that I have described so far. That's all I got. I hope that you enjoy, and I'm happy to answer any question if there are any.
Awesome. Thank you, Luca. Insightful as always, even for a lowly .NET developer like myself. So I do appreciate that. There were a couple of questions coming in actually, and I'll try to run through them. So one, which is actually a really awesome question from Andres that I'm super interested in myself, is when you use the parameters supporting Power Tools, does that use the parameter store extension that you talked about? Do you know?
I'm not sure about that. I don't think so. But I would need to double check on that.
Cool. Related to Power Tools, actually, follow-up question from me. This was obviously a very Node.js heavy talk.
Yeah. Sorry
what about
that,
anyone
Jake.
listening who aren't using Node.js? Can they still use Power Tools? Is Power Tools still an option?
If you're not using Node.js?
Yeah.
Yeah, totally. So Power Tools is available also for C#, your favorite language. And it's available for Java, that is another favorite language of yours, and and Python.
Nice. So it's available for everybody. Power Tools.
Yeah, almost everybody. I think currently on the managed runtime, we're not missing much, but obviously there are other programming languages that are quite popular, or becoming popular, like Rust, for instance.
Yeah, yeah, Power Tools for Rust. That'd be fun. Do I want to commit the time to that? Do I not want to commit the time to that? I don't know. Feels like a lot of effort. But it'd be cool. So the other question around LLRT, there's been a couple of questions actually on LLRT. The first is again from Andres. Do you know, and this probably should have been a question for Richard last week actually, is there a potential timeline for when it's no longer going to be experimental? Do you know?
No, that nothing that is official at the moment. I know that there is a lot of interest, and Richard is working very hard, because I'm seeing the movements inside the GitHub repo, but there isn't a deadline at the moment, or a public one that will, let's say, we can share publicly.
Yeah, cool. And the follow up, I suppose. What about MIDI and Power Tools? Because I've heard of
Mm.
MIDI. It looks really cool. And obviously Power Tools is Power Tools. So if you were using LLRT, thanks for the question, Matteo. It's a great question. Do you know if you can use MIDI and Power Tools with
Yeah,
LLRT?
at the moment, I use LRT mainly for my performance tests. I didn't try with MIDI and Power Tools. I believe that if they don't have anything that is not supported in LRT, and there is a nice table that in the README file that describe what is supported and what is not supported in LRT, they will work out of the box without any problem. But there are some limitation on LRT, and therefore I didn't try them in LRT, but I think that the test will be quite quick to do.
Nice. So if they do work, Matteo, if you do try it, then
Let
please
us know.
let us know. It'd be cool to hear
Otherwise, I will
actually
try
if they do
anyway.
work, because I know at least in the .NET space with native compilation, which is a kind of similar thing in terms of performance improvements, Power Tools, the team are working hard on the support, but there's some kind of caveats if you start to use these high performance tools for working with Lambda. So yeah, it'd be good to test that, see if that works actually. And then a couple of other questions that I'd noted down actually, Luca, that got me quite interested.
Sure.
There was, I think you mentioned, if I understood it right, that you have, at least with Node, some of the libraries are bundled inside the sandbox. Did I understand that right? So you don't actually need to include the library as part of
There
your.
are there is the SDK, AWS SDK that is bundled
Yeah.
there, but usually what we recommend is for the SDK specifically to bundle with your code. And the reason is very simple, because when you want to read from disk, it takes definitely longer than read from in memory. When you are downloading the bundle that is available of your code alongside with the AWS SDK, and you just import what is needed and not everything, we are going to have everything in memory, and therefore will be extremely fast to load. Instead, if you delegate to whatever is available into the runtime, the execution environment, or the sandbox, you are going to it's going to take longer, and also you don't have control on which version you're using. So especially if you're using a specific version because you need for a certain reason, if you bundle it, it's definitely more performant, and also provides you, let's say, security that is not going to blow up in production.
Got you. So if I understand that right, it's that the SDK, if you bundle it in your zip file, when the zip file is loaded into memory, the SDK is loaded into memory with it. So it's already
Yes.
there waiting to be used. Whereas if it's from the sandbox, at the point you make the SDK call, Node's going to try and load that up from the sandbox from the
Correct.
execution environment, right? Okay,
Exactly.
interesting.
But the
Cool.
thing is, bear in mind the new SDK for JavaScript, the SDK v3, is already divided in multiple libraries. Therefore, when you are importing, for instance, DynamoDB, parameter store, etc., make sure that you apply tree shaking and everything as described in the talk. So in that way, you will have like a smaller bundle size. You have just what you need to perform, and is reading from in memory. That is the best of approach that you can have.
Cool. That makes a lot of sense. Matteo, it seems in the chat, is going to go off and give this a try. So awesome. Please,
Amazing.
yeah, that'd be
Let's
cool.
do that,
Yeah,
Matteo.
let us know,
Let's do
Matteo.
live.
That'd be cool. And the last question I've got, at least, is obviously you've talked about quite a few different optimizations there, things like power tuning. Obviously, you mentioned the Lambda architecture right at the start, tree shaking, minifying. Which is the most impactful, I suppose? Like, if you were going to pick one, what would be the one that you'd advise people to look at first?
Okay, so the first one that was the most impactful was caching, because
Okay.
in memory cache with elastic cache is blazing fast. And that's definitely helps a lot, because you don't have to go through RDS proxy and then RDS waiting for the query to respond and defining the indexes and everything. So it's like the fastest, the one that had most impact, I would say. After
How would you
that,
view that? How would you view that then? Because obviously, if I'm a developer working with Lambda today, and I've got, I don't know, Lambda, and maybe I'm not using RDS, maybe I'm using another persistence layer.
mm,
To add Elastic Cache would mean I'd need to add VPCs, subnets, and obviously there's other caching options out there, like companies like Memento.
yeah.
I guess it's not necessarily Elasticache specifically that you're
No.
recommending,
It's
right?
the cache. Let's say in this case, in my case, it was Elastic Cache with Redis, but it could be any other cache, right? So it's even if you do in memory, it could help. I did few tests even with files for where I used, let's say, EFS versus S3. For understanding which one would perform better. EFS, despite its VPC attached, because it requires the Lambda to be VPC attached, is definitely faster than S3 because you don't have all the TLS and shaking that you need to handle that, and you don't have to do for every single sandbox, because we have to remember the EFS is available out of the box for all the sandboxes. And therefore, that means that when I spin up a new sandbox and is VPC attached, that file doesn't have to do any tree shaking, any handshaking or anything. It's literally there, and they can retrieve directly from the file system, like it lives there.
That's really interesting. I didn't actually know that. So when you use EFS, it's one attachment for all of your execution environments, as opposed to a
In the
separate
test that I
attachment.
did, it was extremely fast on that part. I was able to retrieve 1 megabyte of file in 6 milliseconds, if I remember well, because I did a few months ago, against 30 milliseconds.
That's very cool. It's really interesting when you get into stuff like this, isn't it? Because I think normally I would just go to S3. I'd be like, okay, I want to store a file. I'm just going to store that in S3. But actually, yeah, it's interesting when you start exploring these other areas, and actually, EFS
There
being more
are a few
performant.
things. Yeah, I think that sometimes when you're not looking only on the cost, but you're looking into only performance. That was my case. For instance, I wanted to understand what was the fastest way that I can get 1 mega file. You discover, let's say, and you start to think out of the box. You can discover that certain things that are not designed maybe for what the purpose could be extremely interesting. And the other cool thing, considering we are talking about node land, that I believe is interesting, is that you can even use a lazy loading, let's say, just Node.js modules or ESM modules from EFS, because at the end it's like mounted there. So potentially you can create a library and they have some files over there, and you lazy load them when you are in the initialization phase of your function. That is something that I'm trying currently to understand the impact on performance and whatever. And so far in the test that I have done, it seems that is pretty stable with or without that, let's say, lazy import. I don't see, let's say, specific impact on performance that is very interesting in small, obviously, small code bases. But now I want to test with larger code base and see if there is any improvement or any, let's say, issue, because that could open up quite a few interesting outputs or outcomes.
Yeah, so that would be again, just to check my non-node brain understanding. That would be instead of packaging your packages as part of your zip file, you store all your packages on an EFS volume, mount the EFS volume, and then at runtime you lazy load all of them libraries into your code as part of your init. Okay. Cool.
That's a test that I'm trying to do, especially for all the server-side rendering that I'm doing in my spare time.
Yeah. All these non-compiled languages have some really cool things that you can do, right? Like coming from like a compiled language background like .NET and Java, where you've got this compiled thing, having all these cool options where you can I'm just going to put all my libraries over there.
Exactly. It's
Kind of a
it
cool
can
option to
live.
have.
There are people that are saying that the library could live in any endpoint as long as it's accessible online. You can even download it or
Download
use
it at
it.
real time. Cool. Well, there's no other questions that I've seen come in. So any final comments, Luca? Anything else you want to add before we
No,
wrap
the
up?
only thing that I would like to say is like the purpose of this talk was mainly to let's say spark some ideas on what you could do and the importance of optimizing your code, because when you're optimizing your code, you can use exactly the same infrastructure and squeezing in way more requests per seconds. And it's not always the answer that I need to re-architect everything to another, let's say, compute service. Sometimes it's just literally, let's spend a bit of time to optimize where I have. And we have tools like the segments in X-Ray or any other tool that you're using for observability to understand, let's say, how long it takes every single operation that you think it could be a good starting point. And then from there, you can start to optimize slowly but steadily different parts, implementing different architecture, implementing cache, implementing all the different things that you need to do.
Awesome. Well, thank you again, Luca. This has been my pleasure, my honor.
You're welcome.
So yeah,
Thanks
very much
for
appreciate you
inviting
being
me.
here. And yeah, let's catch up soon. And again, thank you everyone for watching. I'll be back live somewhere on the internet in about an hour talking about event-driven systems. And again, on Friday, we've got Daniela and Omid talking about all things Cloudflare workers. So if you're interested in Cloudflare workers, make sure you check that out. So thanks again, everyone, and we will see you all next time.
Thank you. Bye-bye.